Okay. Last week we talked about the collinations at chloride, though they are choline, but they are totally different. The methods of the analysis are also different. So hopefully you can uh, get something from the results that we distributed to you last week. But anyway, for this week, we are moving to the another series, another sets of the analytical, uh, another sets of the parameters, which we generally use to measure in surface water and the wastewater. So mostly we measure the dissolved oxygens uh,
อาจารย์ยังไม่แชร์สกรีน
a screen เอ่อเดี๋ยวแป๊บหนึ่งผมยังไม่ได้เปิด files, class materials, background. You can get the background information about the dissolved oxygens from the documents that I leave it in the files. Okay. The dissolved oxygens, we usually measure these parameters in a case of the surface water, and also sometimes during the BOD analysis. The BOD analysis, uh, we will talk about that again after the midterm examinations, but for the this week, we will focus only on the dissolved oxygens in the BOD analysis, we also have to do the dissolved oxygens. We have to measure the dissolved oxygens. For the BOD, we measure the dissolved oxygens in day zero. So if we are going to analyze today, and then the next 5 days, we have to come back again and analyze for the dissolved oxygens. So we call the DO5. But anyway, in this and today, we will just only do the DO for the general cast for the surface water sample. For the DO, DO is actually stand for the dissolved oxygens. For the environmental engineer, we normally call these parameters as the DO. Okay, we are really pay attention on the dissolved oxygens on the DO in the surface water, because in the surface water, the dissolved oxygens must be at least 4 milligram per liter. Okay, it must be at least 4 milligram per liter. This 4 milligram per liter, it's important, so you have to remember this number because if it's smaller or less than 4 milligrams per liter, most of the aquatic organisms will not feel comfortable to live under such a very low dissolved oxygen concentrations. Only some aquatic species may be very tolerant. For example, the catfish, they can survive even the dissolved oxygen goes as low as 2 milligrams per liter. But for the normal fish or the other aquatic organisms, they don't like to live in such a very low dissolved oxygen concentrations. That is why we need to maintain above a 4 milligram per liter. So in the wastewater treatment process, we need to maintain the reactor under the aerobic conditions. So for the wastewater treatment, we carry out the biological reaction in the reactor. Uh, We provide the oxygens, we cultivate the microorganisms, waste water entering to the reactors and leaving the reactors with the flow rate Q. This is the volumes. This reactor has the volumes of V, and the BOD is given as the S. So we provide the oxygens. Okay, in this reactor, the organic substance which we measure in terms of the BOD uh, will actually react with the oxygens, and then by the microorganisms. The microorganisms can actually utilize and degrade it, and the end products is the carbon dioxide and water molecules, and then uh, this one, the oxygens, it's consumed as we provide the oxygens with the significant amount of the oxygens we provide, the microorganisms we utilize. In this reactor, we need to maintain the dissolved oxygens approximately 1 to 2 milligrams per liter. 1 to 2 milligram per liter, it's large enough, is high enough for microorganisms to utilize the organic substance, and degraded becomes the harmless end products like this. And that is for the aerobic treatment, so that at the end the BOD gets concentration, it's removed. So the concentration gets below the the BOD has to be less than 20 milligrams per liters. This is the standards, the effluent quality standard for the treated water. And then for the BOD, the test, BOD test, in the BOD analysis, we have to measure the dissolved oxygens in the day zeros and compare with the dissolved oxygens in the day 5. So in the day zeros, we measure the oxygens. The oxygen should be very high, like for example, 6 milligrams per liter. And then we keep this bottle for 5 days, and then we measure again the dissolved oxygens. So during these 5 days, there is the degradation, so that some certain amount of oxygen is consumed by the microorganisms. So the dissolved oxygens after 5 days, you will get like a maybe depending on the amount of the organic substance present. So it may be 2 milligrams per liter. So that we can say like a 6 minus 2, it's a 4 milligrams per liter. So that these 4 milligrams per liter can be considered as the amount of oxygen consumed. So this one is the values of the BOD. So BOD, we measure it like this. The dissolved oxygens, these are the significant or the rationale why we have to measure the DO. As for the solubility of the oxygens, as I told you, the typical concentrations of the oxygens found in surface water should be around 7 or 8 milligrams per liter, like that. Why? Due to the Henry's constants, and considering the amounts of the air that can actually dissolve it into the water, the air actually we can consider they are really poorly soluble, as the concentration is only 40, approximately 40 milligrams per liter under the normal conditions, 20 degrees Celsius atmospheric pressure. So this amount of the air can actually get dissolved in water. But as the oxygen concentrations, in terms of the percentage found in the air, the oxygen content is only 21%. So that if we measure only the oxygens in water, the concentrations found would be only 9.2, 9 its maximums, generally under the temperatures like 30 to 30 degrees Celsius, 20 to 30 degrees Celsius. This would be around 7 to 8 milligrams per liter. So this is a normal condition that we usually find in the tropical region. These are the list of the factors affecting the solubility. Just like any other gases dissolved in water, The higher temperature will be the lower solubility. So these are similar to any other gases. For the pressure, so if the pressure is high, of course, gas will get more dissolved. But under the if you measure the dissolved oxygen here in this near the sea levels, but then if you measure the oxygens in the tops of the mountain, if the other conditions are same, you get different amount of the oxygen dissolved. That is because of the atmospheric pressure. The another one is the dissolved salts. The salts means the positive and negative charge ion dissolves in water sample. If the dissolved salt concentrations is higher, so that the solubilities of the oxygens gets lower. So these are the major three factors influencing the solubilities of the oxygens in water. So uh, another thing is normally for the measurements of the dissolved oxygens in the natural stream, uh, usually we measure it on site. So we take the meters. Generally, we call it the O meter, dissolved oxygens meter, just like a pH meter and any other types of the meters. So there is a probe that connected with the meters. So we dip the probe in a water sample, then we get the value. So this value, we can actually rate it and then get that number directly. We don't have to interpolate. We don't have to calculate it, anything. So it's very simple to measure the dissolved oxygens. But the method that I'm going to introduce this afternoon is not dissolved oxygen measurements by using emitters, but it's the same methods we are going to use for the BOD analysis next 2 weeks, 3 weeks, maybe after the midterm examination. You still have to memorize, you still have to come back to these labs again and then check for the methodologies how we analyze the dissolved oxygens. Uh, but anyway, as I told you, the dissolved oxygens we have to measure on site. If we bring the sample and get it back to the labs, some certain amount of oxygen may be gone, or some oxygen in the atmosphere may get dissolved into the water sample. So you have to be careful if you want to collect the samples and analyze it somewhere else. Even we collect the water sample from the ponds in front of our building and then get it to the fifth floor of the research building to analyze the dissolved oxygen. Even such a very small distance, such a very few minutes traveling from the ponds to the labs, still there is a possibility of the oxygens may get into and then get out from the water sample. So we have to be careful. Samples need to be fixed. Fixed means preserved. So whenever we collect the water sample for the dissolved oxygen analysis, we should actually fill water samples until it full of the bottles. Don't leave any space or let the air get inside. So once it's full, then we just close the lids tightly, not allowing the dissolved oxygen from outside to get inside. And on the other hand, the dissolved oxygen in water get outside and analyze it within the just periods of times. Uh, Normally, water sample we have to keep it on ice if we carry it for long distance or longer time. We need to prepare the special bottles. We need to fix the water sample sometimes. So these are the things that we need to be aware. It's something different from the other parameters analysis. So for the determinations of the dissolved oxygens, for the dissolved oxygens, what methods we are going to do it in the lab. The methods that I'm going to introduce to you is actually called the Wingler methods. the Winkler method. Winkler method. What is the Winkler methods? Actually, there is the conventional Winkler methods and the modified Winkler methods. But anyway, the concepts are the same, but just some chemical additions are slightly different. Anyway, okay, this one is the table showing the dissolved, saturated dissolved oxygen concentrations. You can see the values in this table. These values show the dissolved oxygen saturated concentration, saturated DO actually. As the temperatures increased, the concentrations of the oxygens in the water it's also decreased. Here we just consider in the case of salinity it's 0 grams per kilograms, and this can be considered as a fresh water. Fresh water, they're not supposed to be any salinity dissolved, but some small amount may be there, like a 5 grams per kilogram. But anyway, this is the fresh water. So say like at the under 30 degrees Celsius, if you measure the dissolved oxygens, the saturated DO that you're going to find it's approximately 7.55. So this is the saturated DO. Normally, you can measure and you will get lower than 7.5 if the temperature is 30, because this is the saturated concentration. But in some cases, very special cases, the dissolved oxygens may go very high, even that our temperatures is 25 or 30 degrees Celsius. They're supposed to be 8.2 only, but sometimes it goes up to 14, 15. That is also possible. But that case, we only find when that surface water are contaminated or are experienced the algal bloom problems. So extra amount of the algae go up in the ponds like that during in the afternoon, like at 3 o'clock or 4 o'clock in the afternoon. Uh, the photosynthesis rate reach the maximums. So the end products of the photosynthesis, we all know that it's the dissolved oxygens. It's the oxygens. So oxygens concentrations in the afternoon, sometimes it goes beyond 10 milligrams per liter. In that case, we normally call it in the supersaturated conditions, not saturated condition, supersaturated conditions. So it comes like this only when there is the extra amounts of algae growth in that pond. So this phenomenon we normally call the eutrophications. We normally call it eutrophications. Uh, eutrophications. There is the algal bloom. So you see the ponds will turn green. The entire ponds will turn green. This is due to the extra amounts of the algae goes up in that pond. This problem arises due to the contaminations of the nitrogens and phosphorus from the domestic waste. So nitrogens and phosphorus are normally considered as a nutrient. So they can actually enhance the growth of the algae. And the problem is the algae, all the algae, there are thousands of species of algae. So some algae also produced, can actually produce the toxins. So this water becomes a toxic. It's not recommended for the used for the using as the raw water sources for water productions. And the problem with this point during the daytimes, especially maybe around 3 to 4 o'clock in the afternoon, the oxygen concentrations will reach the maximums. But in the nighttime, as they are all living species, there are no photosynthesis during the nighttime. These algae, these algae, they also consume the oxygens, even though in the night times they produce a lot. In the daytimes they produce a lot, but the levels of oxygen will drop dramatically during the night time, and sometimes it goes even very near to zero, especially during the early morning, like at 4 o'clock, 4 or 5 a.m. in the morning. So sometimes it goes even to zero. So no uh, uh, aquatic organisms can actually survive. They have to move up to the surface and then spend their life near the water surface. So like this. So this is the critical times. During the daytimes, it may goes beyond 10 milligrams per liter, but during the night times, it may be 1 to 2 milligrams per liters only, or sometimes it gets even zero. So that in the early morning, in a ponds having a problems, eutrophication problems in the early morning, we will find some fish die and floating on the surface of that pond. That is occurred uh, uh, very often in many ponds in Thammasat campus, especially in our campus. We have a lot of pond experiencing eutrophication problems. So this is the problems with the dissolved oxygens when there is the there is the algal booms found in the ponds. Another thing with the dissolved oxygens is that when we disposed the waste into the stream, so if we drop the waste here, this is the wastewater uh, with the flow rates of QW, and then the concentrations of the organic substance is given as the S. So we dropped this into the stream, and then this one is the river flow rate. The river flow rate is given as the QR. So initially, the concentrations of the oxygens is coming like this. This may be like a 7 milligrams per liter, 6 to 7 milligrams per liter. But once it reached the point where the wastewater entered to the stream, the dissolved oxygen concentrations will drop slightly, and after that, the organic substance which came along with the wastewater will uh, be degraded by the microorganisms using the oxygens and to produce the harmless end products like this. So the oxygens in the river should drops a little bit before going down like this. This is the oxygen concentrations profile. So it drops because of some certain amount of oxygens in the river gets utilized until it reached the minimum value. The minimum dissolved oxygen concentrations found, normally we call the critical DO. Critical DO. So this critical DO should actually be greater than 4 milligrams per liter. If the concentrations of the organic substance entering to the stream is high, maybe the DO will drop uh, to the level where the concentrations uh, is less than 4 milligrams per liter. So this will create the problems. Type 2, it's actually the strength of the pollution. It's higher than the type 1. But if the pollution is entering to the stream, it's extremely high. The DO levels will drop it until it gets zeros. And during this distance, uh, this length, there will not be any dissolved oxygen found in the water. But anyway, after the organic substance get completely degraded, the oxygens from the atmosphere uh, will again get into the water through the diffusions, uh, so that the oxygen levels can actually be recovered again at the end. But anyway, it depends on the strength of the waste entering to the stream. So if the concentrations of waste is high, the distance with no oxygens will also be longer. So this is the problem associated with the dissolved oxygen. So we can actually use these parameters to monitor or to manage the this water quality, especially the surface water quality, not the groundwater. So groundwater, we don't have to worry about the dissolved oxygens because it's underground. So very less amount of oxygens can actually get dissolved in the groundwater. So mostly the groundwater, there will not be any problems about the oxygen, but on the other hand, more carbon dioxide get dissolved. So groundwater becomes more acidic as compared to the surface water. So this is a kind of uh, environmental problems when we talk about the dissolved oxygens. Uh, the methods of the analysis. The methods of analysis we are going to use in the labs is called the acid modifications of the Bringler method. I just want to explain about the reactions which we will uh, analyze in the labs before talking about the procedure. So this one, uh, these are the reaction. Dissolve oxygens in water. Dissolve oxygens in water. Usually we do it like this. Uh, we use the bottles with the volumes of 300 milliliters. 300 milliliters water, the BOD bottles. Actually, this bottle we normally call the BOD bottle. This bottle we also use to analyze the dissolved oxygens. And we also use to analyze the BOD because the name is the BOD bottles. The volumes is 300 ml. So we filled a water sample until it reached the bottleneck, and then we close it tightly. Uh, Before the analysis, we prepare the sample like this, and then there might be some oxygen dissolved inside. So uh, when we want to analyze the dissolved oxygens, we just open this lid. We simply do like this. So we first added manganese sulfate, MnSO4, 1 ml, and then just followed by the solutions called the alkali iodide acid, 1 ml. So 2 ml are added. 2 ml are added now. This one is a solution. Manganese sulfate is the solution. Alkali iodide is also a solution. So the volumes is 200 mLs. So another 2 mLs of the solutions are added. So the total volume at this moment, after adding the alkali iodide acids, the total volume will be 302 ml. So what happened after adding the manganese sulfate? Manganese sulfate, the color is the pink. So once we add it into this bottle, what will happen? The dissolved oxygens inside the water sample will react with the manganese sulfate, and the hydroxides coming from the alkali iodide acids will also react with the manganese. If the oxygen is present, manganese react with the oxygens, then it produced the brown precipitate of the manganese oxides. So this one is actually manganese 4 oxide. Okay. On the other hand, we can rewrite this equation like this: manganese hydroxides react with the oxygens, and then we get the manganese 4 oxides. This one is the precipitated forms, brown precipitated. And after that, what will happen? So brown precipitated occur. This brown precipitated of the manganese 4 oxides will further react with iodide under the presence of the acid. So once brown precipitate is formed, we will allow them to precipitate it around 1/3 of the entire volumes. And after that, we add 1 ml of the concentrated sulfuric acid. So once the concentrated sulfuric acids are added, manganese 4 oxides get dissolved. So once it gets dissolved, what will happen? Under the presence of the acids, so this one actually comes from the H2SO4. This one actually comes from the alkali, iodide, acid. Manganese oxides get dissolved, becomes manganese 2, and then iodide turn it to iodine. Now, after adding the concentrated sulfuric acids, you will get the solution with the browned color. This is the colors of the iodine. After adding the concentrated sulfuric acid, you will get the brown color. It's a colors of the iodine. And then what will happen to the iodine? Last time we were also using the iodine as the we actually used the iodide, and then that iodide reacts with a chlorine. A chlorine actually turned the iodide into the iodine, and then we analyze the iodine using the thiosulfate. So this time is also the same thing. This iodine comes from the formations reaction. This iodine will then present in water sample, and then we titrate against the sodium thiosulfate. So after adding the concentrated H2SO4, the colors of the solutions return brown. So we removed 99 ml of the solutions. Why we have to remove a 99 ml? Because here we only need we only need 200 ml. 300 ml, we only need 200 ml for the reactions. The chemicals we are going to prepare, we react with only 200 ml of the sample. This is the technical problems, but after adding 2 solutions previously, the total volumes becomes 202. That is why we require 201 ml for the titration, but the volumes of this bottle, it's 300 ml. So we have to remove 99 ml. 300 ml, remove 99 ml, so that the volumes left is just 201 ml. So we only take these volumes and then use these volumes for the titrations. Titrations against what? Against the sodium thiosulfate. The concentration is 0.025 normal sodium thiosulfate. H5H2O. Okay, so this iodine react with the thiosulfate. This return to iodide again, and during the titrations, we also use the starch as the indicator. Once the iodine is present, when we add the starch, you will see the blue color. It depends on the concentrations. If the concentrations is too high, it turns dark blue. So once it turned blue or dark blue, we titrate this against these sodium thiosulfates until it becomes a colorless. So become colorless means the iodine it's completely turned it into an iodide ion. Uh, then we recorded the volumes of the thiosulfates used. 1 ml of the thiosulfate consumes is equal to actually equivalent to 1 milligrams of the oxygens. For example, if we tried it against the sodium thiosulfate and it consumes 5 ml, 5.5 ml of the thiosulfate solutions, it means that oxygens dissolved oxygens found in this sample is also 5.5 milligrams per liter. Okay, so each milliliters of the thiosulfate is equivalent to 1 milligrams of the uh, oxygens. Okay, so we get the number directly. That don't need to uh, calculate it. Okay, so these are the theory behind the reactions which occur during the titrations. Okay, so that's all for the dissolved oxygens for the background informations. Now we'll move to the protocol. My assistant, he has prepared this presentation. It's quite a good presentation so that you can see how it works. This one is the methodologies for the dissolved oxygens analysis. Add the samples into 300 milliliters of the BOD bottle. Put the 1 ml of the alkali iodide solutions, followed by the 1 ml of the manganese sulfate solutions. It is very simple, just 1 ml. This one is also 1 ml. And then mixed in water for a few times. And after that, add 1 ml of the concentrated sulfuric acid like this. So after additions of the sulfuric acids, then the precipitated forms of the manganese oxides will redissolve. So once it redissolved, the reactions with the iodides will occur. Then the iodines will form. So once the iodine will forms, then we measure by using by titrating against the 0.025 normal sodium thiosulfate. So we add the starch solutions at the indicator, and after that we removed 99 ml of the solutions and recorded the volumes of the thiosulfate used. So 1 ml of the sodium thiosulfate is equivalent to 1 milligrams per liter of the dissolved oxygens. So it's something like this. For the dissolved oxygens analysis, we actually do it in the labs very often. If you are interested, you can visit our labs. I'm not sure if some of you are staying around the campus. Sometimes you can come to the labs and have a look how we analyze the dissolved oxygens by using this trimetric method.
อาจารย์ครับเราใช้บอทเทิลเดียวหมดเลยใช่ไหมครับอาจารย์
No. Okay, we only used one bottle for the dissolved oxygens analysis. Yes, that's right. We only used one bottle, one sample, one bottle, just to get the dissolved oxygen concentration. But if we analyze the BOD, we need too many bottles. we need 20, 30 bottles. One sample, it requires 9 bottles for the BOD analysis. But for the dissolved oxygen, one sample, just 1 bottle. Okay. Do you have any question regarding to the methods of the analysis? Actually, we have the presentation, another presentation. I'm not sure where do I keep. So it's this one. So let me just try to find that presentation. Mm. Or I must left that presentation in other classroom. Okay, so it's here. Okay, so this is the another presentation. So I will will leave these presentations in the other class. So this is the bottles I'm talking about. It's a 300 ml BOD bottle. It's a basically the brand. We normally use this brand Wheaton. This is the brand of the BOD bottle. The volumes, it's once we close this lid, it's exactly 300 ml. Chemical we used consists of the manganese sulfate, alkali iodiazide, and concentrated sulfuric acid. Just only 3 chemicals. And each chemicals we only require 1 ml. So 1 from the manganese sulfate, and 1 for the alkali iodiazide, and 1 for the concentrated sulfuric acid. The titrant is this one. Sodium thiosulfate 0.025 no more. The indicators we use the starch solutions are actually what you are supposed to do in the labs, in the today's labs. You are supposed to measure the diurnal variation. Do you know the diurnal variation? I will assign you to measure to establish this curve. In fact, you have to establish this curve if we are not in the situations of the COVID outbreak. Normally, you have to do this at each hours. In every hours, maybe every 2 hours, you have to measure the dissolved oxygen. So after measurements, then you take the information and plot the curve. So some of you have to come in a very late night and also in the early morning to get a 24 hours information. So every 2 hours, you have to measure the dissolved oxygen in the assigned ponds. These are the ponds. Some ponds, the water turn green. That is due to the eutrophication problem, as I said. Some ponds, maybe the canals, I'm not sure this one. The qualities of water, it's quite good. But some are clearly see the colors once we collect the water sample, it turned green like this because a lot of algae going inside, and the water quality it's not good, so it's really turned turbid. So the first step, so just collect the water sample and you just take the bottles and collect it directly. Uh, Put the water into this bottle until it's full, then close the lid. So you can put the waters up to the bottle next here. So once you close, some amount of water will spill out. That is okay, because we don't want any bubbles left inside this bottle. Closed tightly like this. So just add 1 ml of the manganese sulfates and 1 ml of the alkali iodide acids. So these two solutions. So once you add it, the manganese oxide is formed. The precipitate, brown precipitate, this one is the manganese oxide. So we let them, after checking, inverting, mix by inverting around 25 times. So just mix invert like this. Then let this manganese oxide flux settles to at least 1/3 of the bottle's height. So you get a brown precipitated like this. But be careful, if the white flux is observed, it's a flux of the manganese oxides. It means that there is no dissolved oxygens. Okay. Uh, which okay, it's here. So our first equation, I just explained about the dissolved oxygen presence react with the manganese sulfate. But anyway, if there is no oxygen present, so it goes to the first equation, stoichiometric equation. If there is no oxygen presence in water sample, for example, wastewater, normally we will not find any dissolved oxygens. I'm not sure whether the quiz is asking about the typical concentrations of the oxygens in wastewater or not. If it asks about the dissolved oxygens in wastewater, so the correct answer should be absolutely zero. Normally wastewater, they are not, there is no oxygen presence. So if there is oxygen presence, it's not the wastewater. Okay, why? Because wastewater, it contains the organic substance, and if the oxygen is present, all the oxygens will be utilized by the microorganisms to oxidize the organic substance or the BOD. So there will not be any oxygen presence in wastewater in general. That is why if you collect the water samples from the canal, polluted canal, there will not be any oxygen left. So if there is no oxygen, what will happen? Additions of the manganese solutions is fine, but soon after you added the second solution, alkali iodide acids, you will see the clear white precipitate of the manganese hydroxides. This one is the white precipitate, but this one is the brown precipitate. So it's a completely different. That is why in this presentation, these are the sample which there is no oxygen presence, but these are the sample. There is some certain amount of the oxygen left. Okay, so these are the difference between the first and second reactions in the previous slide. So we add 1 ml of the concentrated sulfuric acids. So after adding these acids, what will happen? The precipitated forms of the manganese oxides will redissolved and becomes and iodine is formed. I2 is formed. So after additions of the sulfuric acid, so we have to mix several times by inverting the bottles. Then remove 99 ml of the solutions. Performs the titrations against 0.25 normal soft sodium thiosulfate. So we do the titrations until the pale straw colors appear. Initially, it is really brown, but after additions of the thiosulfate, so after some certain amounts is added, the colors of the solution turn to a pale straw a color. So until reaching the pale straw colors, we added a few drops of the starch solutions. Starch, if the iodine is present, you will see the blue color or dark blue color. And then immediately titrates, continue titrations until the blue color is gone to becomes a colorless. This one is 201 ml. This one is 201 ml. So the colors of the water may be different, depends on the original color. The bottles 23 and the bottles 19. You can see the how it changed. This is the water sample. See this bottle, the original colors of this bottle, it's initially green. That is why at the end, even we said like we have to do the titrations until it becomes a colorless, but it's not really a colorless because the original colors of this sample, it's not clear. Okay, so it just remains like this. Then there is no need for the calculation. So whatever the amounts of the thiosulfates you have gotten from the titrations, it's equivalent to 1 milligrams per liter of the dissolved oxygens. In fact, this should be a 1 ml, not 1 mg. Okay, 1 ml. Alternatively, we can use the DO meter, but yes, but DO meter it's quite simple. You just essentially switch on the nuts here and drop this probe into the water where you want to measure the dissolved oxygens. So just wait for some time. Then the values will show how many milligrams per liter of dissolved oxygens present, or sometimes it measures in terms of the ppm, or sometimes it measures in terms of the percentage. Okay. So these are the methodologies about the dissolved oxygens analysis. Okay, regarding to the methods of the analysis, do you have any question? Do you have any question regarding to the methods of analysis? If no, then we move to the results that you will receive that result at 3 o'clock. So the results will be something like this. As I tell you, these labs actually you have to measure the diurnal variations. Diurnal variation diurnal แปลว่าอะไรฮะคำนี้แปลว่าอะไร diurnal แปลว่าอะไรฮะแปลว่าอะไรครับ diurnal แปลว่าอะไร diurnal variation แปลว่าอะไร
ไม่ทราบครับอาจารย์
เปิด dictionary สิ
กลางวันป่ะครับ
อะไรนะฮะ
กลางวันหรือเปล่าครับ
กลางวันนะฮะระหว่างวัน
หลายวัน
นะฮะหมายถึงว่าเป็นแบบช่วงระหว่างวันนะฮะก็คือ during 24 hours variation นี่แหละนะฮะอันนั้นก็คือ diurnal variation นะ 24 hours during a 24 hours so you have to measure the diurnal variation that is why the results comes like this so if you have a look at the results at every 2 hours you are supposed to measure the dissolved oxygen by using the methods that I suggest. These results, I'm not sure the results belongs to which group. It's a group 2. Group number 2. This one is the results that are obtained from the measurements of the dissolved oxygens from the ponds near Chiang Rak Terminal 2. What is it? Chiang Rak Terminal 2, so I'm not sure. Gate number 2. It must be the gate number 2. Terminal. Bus stations. Van stations. I'm not sure what is it, but anyway, just forget about it. It's the pond somewhere in Thammasat campus, in Rangsit campus. The physical characteristic of this ponds, it's a green and turbid, moderately green and mild turbid. It's present. Then the pH we also measure along with the time. Mostly the pH is there is a slightly variations in terms of the pH during the midnight. It is 7.26, but during the evening it goes above 8. And on the other hand, for the mLs of the sodium thiosulfates, these are the values we obtained from the titrations. If you want to determine the amounts of the oxygens dissolved, so for example at the midnight, so you take 6.6 subtracted by 4.5, so it's equivalent to 2.1 milligrams per liter. So it means that in the midnight, the dissolved oxygens is only 2.1 milligrams per liter. So aquatic organisms are not feel comfortable to live there. 4 o'clock, it goes very low, only 1.3 milligrams per liter. But during the daytimes, for example, 4 p.m., so it gets even above 10. So this is really super saturated conditions. Okay, so you can find out and then get these results and then prepare the lab reports. I think for this kind of results, you probably have to plot the curve and discuss the problems associated with this port. What about other versions of the results? Okay, it's also the same. So you may have to plot the results obtained from the titrations. This one is the measurements of the dissolved oxygens from the river. And for the results of the group 1, group 1 also obtained the results from the Chao Phraya rivers. It's the river So the rivers, the pattern, water quality, hydrological characteristics are totally different from the ponds. River and the lake, the hydrological characteristics are totally different. The ponds is like this. The ponds or the lake, uh, the volumes of the ponds or the lakes are very large as compared to the inflows and the outflows. Inflows and outflow, it's very small as compared to the volumes. But the river is nothing but just the streamline. Uh, there is the inflows and there is the queue. So why the dissolved oxygen, critical dissolved oxygen shift to somewhere in the downstream. This is also because of the river, it has the flow rate. Okay, the minimum oxygen concentrations never been found at the point of discharge, but we typically found it some certain miles away from the mixing point or the discharging point, because the water in the river that is flows. So critical DO will never happen, will never occur at the point of discharge or the point of mixing. That is why this curve comes like this. This curve normally we call it DO sect profile, DO sect profiles. Okay, in the polluted stream. There was one episode in the past. I'm not sure whether uh, you have ever heard it about it, this news or not, but several years ago, I think almost 10 years, uh, in the Chapya River, uh, long time ago, there was a boat uh, carrying the molasses. Do you know molasses? Molasses is actually the byproducts from the sugar production industry. We get the sugar, which was made from the sugar cane. So we get the sugar, and then the byproducts of the sugar productions is the molasses. Do you know molasses? It is very sticky and very high viscosity. So I will just search for the photograph so that you can see it, how it look. It's not really a sweet, okay, but it's a kind of waste. We actually used molasses as a raw material to ferment the alcohol. We use this molasses to produce the ethanol. So in the ethanol production industry, they use the molasses as the raw material. It's not a sweet, okay? It's not the things that we should eat. But maybe this thing seems to be something we can eat. But in fact, the molasses that I'm talking about uh, cannot be eaten. Maybe something similar to this one. Okay, so this is a kind of byproduct from the sugar industry. And the thing is, one day the boat carry out the molasses. They actually sink it in the Chapaya River. The boat carry out the molasses, sink it in the Chapaya River. What will happen afterward? The thing is, the molasses is basically it's really organic substance. It's really an organic substance with the very high organic contents. It's 100% the organic substance, but I mean the organic content is higher. So it's pure organic. Huge amounts of molasses goes into the Chao Phraya River. So what will happen next? The oxygens in the Chao Phraya rivers quickly dropped, just like what happened, what I showed you in this figure. So if we measure the oxygen level, so it just goes like this. So as it is the organic substance, the oxygen levels in Chao Phraya rivers, it's all gone. Some certain mines downstreamed. So just like a type 3 pollution. Long distance after the boat sinks, it gets recovered. So the farmers who actually do the aquaculture farms here along the Chao Phraya rivers, they really suffer because all the fish they goes up in the cage in the Chao Phraya rivers, they are all die because they are actually lack of the oxygen. So these people, they really suffer, and then finally, the pollution control department, they look for the cost, and then they ran the model just to predict the dissolved oxygen concentrations in the Chao Phraya River right after the boat sinks into this river. So that they have found that, okay, some certain mines that it's no oxygen present. So based on the information obtained in model, the PCD, they take this information and sue this company, the boat's companies, the boat's owner, and then calls for millions of compensations to these people and for the environmental damage. But at that time, these people, they don't actually believe that the cause is due to the boat sinks, the boat scaling the molasses sinks in this river. Because in the front of, in this area, there is the, the industry, the monosodium glutamate production industry, Ajinomoto or something, I'm not sure, but they are producing the monosodium glutamate. So there is they believe that this industry, they discharge some wastewater into the Chao Phraya River. So at first, this industry were blamed because most of the people believe that they are the one who caused all the aquatic organisms along the Chao Phraya River die. But actually, as to me, as we are the environmental engineers, we know that it is not because of this industry. There is a flow, so this must be due to something happened in the upstream, which is the both accidents here. And it happened twice, it not just happened only one time, it happened twice. So in the second times, it happened again. But second times, the people, they experienced the situation so that they actually remove the cash and put it somewhere, or they put more oxygen aerators into along with the river bank. But still, there are some aquatic life die, especially that's a stingray. Do you know that stingray? The fish with เขาเรียกว่าปลาอะไร stingray เนี่ยนะฮะ
ปลากระเบนนะครับ
ปลากระเบนใช่ that size is as large as 1.5 to 2 meters die. It's unbelievable that the Chao Phraya River has such a very huge string crane. So due to this episode, we had learned that in Chao Phraya River we also have a big string crane living inside. So this situation actually happened several years ago. So uh, these government agencies, they ran the models and they take this information and sue this company, the boat's owner, and finally they actually win in the court. This company has to compensate uh, some to the governments and some to the farmers in this area. So this is the story about the dissolved oxygen concentrations, and I think you can, based on these results, you can prepare the report. Okay, with respect to this report, do you have any question regarding to this report? Sorry, to the lab's results? No? Otherwise, we will go for the uh, last week lab report. Normally, when did you prepare the report? The dates of submissions is last night, midnight. I'm not sure. Most of you have finally completed the report yesterday anyway. So previously you have when started and you started yesterday's evening. I'm not sure whether it is like that. So if it is like that, maybe these labs, uh, can we just assign you to submit it tomorrow night? Submissions of the report next week or this week, it doesn't matter because at the end you will do it on the night of the submissions anyway. Okay. เศรษฐโรจน์อยู่ไหมฮะ So what you have gotten from the analysis, the results? Mm, this report is not completed. There is no discussion. Be careful. The reports, it's accounted for 30%. It's a big portion. So with this report, I will grant you like a less than 5 out of 10 for the reports like this. So and what about other?อันนี้ใครอ่ะพันนเชษฐ์เหรอมีไหมฮะชื่อนี้
นามสกุลค่ะอาจารย์
อะไรนะ
นามสกุลค่ะ
แล้วคุณชื่ออะไรอ่ะ
พิชาพัฒน์ค่ะ
อ๋อโอเคเอ่อบางทีมันก็ขึ้นนามสกุลก่อนนะบางทีมันก็ขึ้นชื่อก่อนนะฮะ so what you have gotten from the analysis อะไรนะพิชพัฒน์ใช่ไหม what conclusion can be drawn from the analysis
ก็คือหนูขอเปิดแป๊บนึงนะ
อาจารย์ยังไม่ได้แชร์สกรีนเลยครับ
ยังไม่ได้แชร์สกรีนเหรอ
ครับไม่มีใครเห็นนะครับ เห็นแต่อาจารย์
โอเคอ่ะ
ก็คือว่าจากที่เขาแบบได้แนะนำมาว่าamount of chloride นะคะ concentration มันไม่ควรเกิน250แต่ว่าในจากที่หนูคิดได้มาจาก calculation นะคะมันมีตรงของ tap water ที่มันเกิน250
tapped water which one is a tapped water so you are talking about the chloride
ใช่ค่ะ
which one is the tapped water it's a bit difficult to find the information this may not be a good idea to present the results like this so where is the tap water on this one
ใช่แล้วก็ average chloride นะคะที่ได้
average chloride where is it อยู่ไหน
ด้านขวาค่ะด้านล่างลงมาหน่อยลงมานิดนึงค่ะ277
3,000 something อ๋อโอเค
ใช่ก็คือเกิน250ตามที่เขาได้แนะนำมาแต่ว่าของอันอื่นนะคะ effluent กับ influent น่ะมันได้ต่ำกว่า250ซึ่งมันก็ยังอยู่ในเกณฑ์ที่เขาแบบไม่ควรเกิน250
no what samples do you analysis last week so you have influence you have effluence and the last one is the tapped water influence and effluence I assume this must be a wastewater samples so if it's a wastewater sample you shouldn't compare with the tapped water chloride standard because in case of the wastewater it can be I think there's no chloride standard for the wastewater so 250 you can compare to the tapped water only because wastewater we are not interested in the chloride measurements. Some other related parameters may be the TDS, total dissolved solids. The TDS in the effluent should not be exceed 3,000 for the wastewater. If I'm not sure if I'm correct, I think it's a 3,000 for the TDS. It's difficult to, I mean, the way you present the results in the table like this is really difficult to look into to understand it. And the significant figures, the concentration should come like a with no decimal. You should make like a 278. That's enough. And if this is the influence, if this is the wastewater, the chloride it's 71, and the effluent it is 240. So it's increased a lot. Did you discuss about it this point? Why the chloride concentrations increased a lot? So how does it comes? So it increases from 71 to 240.
หนูไม่ได้ discuss เรื่องนี้
Okay. So this is the point you missed. And what about the other parameters? Have you considered conductivity, TDS, and the salinity?
อาจารย์ครับไม่ค่อยได้ยินเสียงอาจารย์นะคะ
ฮะไมโครโฟนผมก็ปกตินะ ได้ยินคุณเปิดลำโพงดังๆหน่อยนะไมโครโฟนผมก็ปกตินะ เดี๋ยวถ้าพูดดังๆเดี๋ยวคนอื่นเขาจะมาเคาะห้องป่ะเดี๋ยวแป๊บนึง okay. I was just talk about the results of your friends' reports. So I think this one and this one, as this is the influence and this one is the affluence. So I'm not sure about the value. I assume this must be a wastewater sample. So if it's a wastewater sample, just imagine wastewater entering to the system, properly wastewater treatment plant, and then it come out as the effluents. So there is one thing you should make a remark. Chloride in the influence, it's only 71 milligrams per liter. But at the end, you are getting up to 240 milligrams per liter. So there is a need for discussion here. Why the treatment increased the concentrations of the chloride? How come? So this is the point you should actually discuss. And the other thing is other parameters. You're getting the conductivity values. You're given the conductivity value, TDS value, and salinity value. What are the unit? So this value, in fact, should link with the chloride concentrations you have got it from the analysis. This one are this one is the 10,000 something. Are you sure? Conductivity. I'm not sure about this result because just imagine that TDS is above 10,000 milligrams per liter. I'm not sure. Just check again. This is very high. And what about the chlorination? Okay, so these are the points that you might miss. And then the values you obtain it from other analysis, conductivity, TDS, and salinities. Actually, these parameters has very close link with the chloride concentration. In fact, you should somehow compare this value, at least the trend. And what about the chlorination? Chlorination. How about the chlorinations? Free chlorines.
ถ้ามันไม่ควรเกิน2ค่ะ
For the chlorine. In fact, for the chlorine it's not a kind of standard like other parameters. When we talk about the hardness, we don't want them above 150 milligrams per liter as calcium carbonate. When we talk about the turbidity, we don't want this value to be above 5 NTU, especially for a case of the drinking water. We want them less than 5 NTU, but free choline is not that kind of parameters. We just monitor choline. We want choline presence in water. Okay. If it goes higher than the 2 ppm, it's okay, as long as it's not go beyond a toxicity levels. The recommended values should be in the range of 0.2 to maximum 2 milligrams per liter. If it goes beyond 2, if you find higher than 2 milligrams, it's okay. In fact, it's okay as long as it's not 5 or 10. Okay, it doesn't matter. So the presence of the choline indicates the water is safe from the contaminations of the coliform bacteria or some kind of the pathogens, because pathogens will be inactivated if the choline is present. Okay, but if the choline presents like a less than 0.2 milligrams per liter or 0.2 ppm, this you have to add more choline. Okay, the samples that I have given to you is the samples we collected from the building, high-rise building. This building received the tapped water from the Metropolitan Water Works authorities. They actually produce the tapped water and distribute it throughout Bangkok. So this building received the wastewater from this agency, and then water get into this building and being collected in the underground water tank. And this tank we connected with the pumps, and the pumps will transfer water, keep it in the rooftop water tanks again before distributing the water to each floors to the consumers living in each floors. So this is the system. Okay, we collect the water sample from 3 points. The first one, the tapped water, is here. This is the point 1. So tapped water before entering to our system. Then the underground water tanks. This is sample number 2. The last one is the rooftop tank. It's the sample number 3. Okay, so 3 samples were analyzed, and in here, everywhere the choline, especially free choline, should be like a in a range of 0.2 to 2 milligrams per liters of ppm. So this is according to the criteria set up by the municipal Metropolitan Water Works Authority. But the Department of but the Ministry of the Public Health, they suggested the free choline residue should be in the range of 0.2 to 0.5 ppm. So at least it should be there. So if sometimes it goes beyond 2 milligram per liter, like if we find like a 4 to 5, it may be okay. At least it's there, because at the plants, water treatment plant from the clear well, they will apply the chlorine until it gets like a 5 ppm. But during transportation, some certain amount of chlorines lost. It's the nature of the chlorines. So not all will still present. Some certain amounts of the chlorines may be vaporized. So at the consumer's house, so it may reduce to around 2 milligrams per liter or slightly higher. But anyway, it should not be less than 0.2 ppm. If it's less than 0.2 ppm, pathogens will be very happy so that they can grow up in the distribution system or a water container. So you have to check whether if it is less than 0.2, if it is higher than 2, maybe it may be okay, but it should not be higher. It should not be too high, like a 10 ppm, because if it's high, then it is really smelly. People try to object to use that water. So this is the parameters we just use to monitor the qualities of tapped water or the water we are going to use for the consumption. It's not a kind of standard. It is a kind of monitoring parameters. So if we can maintain the chloride within this range, we are sure that we will not have any pathogens present. The total coliform bacteria will never been found in the sample if the chlorine is there. So this is the parameters. This is the issue related to the chlorine. It is something different from other parameters you have done it before. So we have 3 samples. Now, what about tapped water? Okay, tapped water you get slightly slightly higher than the ministry, the criteria suggested by the Ministry of the Public Health. But this is okay. What is this? This is the underground water tanks. But the rooftop will have the problems. Rooftops is less than 2.2 ppm. So in this case, you should actually recommend it, the persons who are in charge, who are taking care of public water supply system in this building, you should recommend them to put more chlorine. They should actually apply chlorine somewhere, extra amount of chlorine added. Although the Metropolitan Water Works Authorities MWA, they added up to 5 ppm, but at the end, after long time, long distance transportation, some certain amount of chlorines we get lost. So in the front of our house, consumer's house, it may not be 5, it remains only 1. It may be due to this morning, I was talking about the HRT. What is the HRT? The time that the water kept it inside the chamber. This HRT is equal to V divided by Q. So if the volume is too large, HRT will be too long. So if we keep the water inside this tank for too long, for longer time, there is a chance of the chlorines to get vaporized. So maybe if we really look into the problems, you may suggest them either to put more chlorine or to actually reduce the HRT, reduce the times that they keep the water inside this tank. How we can actually reduce the HRT? We can reduce the HRT only when we reduce the volumes of the tanks. So how can we reduce these volumes of the tank? Because it's already built up. It doesn't matter. We can actually set up the floating switch and then allow them to work with only these volumes. There is no need to use it the entire volumes of the underground water tanks or the rooftop water tank. Okay, so this is the issue related to the coordinations. I'm not sure whether you discuss this point or not. I think you have missed many points according to the discussion.
ขอเติมได้ไหมคะอาจารย์หมายถึงว่าหนูขอกลับไปแก้ได้ไหม ขอส่งเรทนิดนึงได้ไหมคะอาจารย์
เอางั้นเหรอนะฮะ
ก็ให้ทุกคนเลยก็ได้ค่ะอาจารย์
งั้นเรากลับไปงั้นทุกคนลองกลับไปรีไวซ์ใหม่นะฮะแล้วก็ส่งมาในโพสต์ต่างหากแล้วกันนะครับ
ได้กินกี่โมงคะอาจารย์
ภายในวันพรุ่งนี้ก็แล้วกันนะครับ
อาจารย์ครับ
มีหลาย
ต้อง
point
ทำใหม่เหรอครับ
อะไรนะคุณก็
ต้อง
แอด
ทำใหม่เหรอ
เพิ่ม
คะ
เข้ามาคุณก็แอด discussion point พวกนี้เข้ามานะฮะแอดเฉพาะ discussion ก็ได้ถ้าif you wish to revise but if you are okay with the report that's fine but if you want to revise the discussion you can submit it within tomorrow
เที่ยงคืนใช่ไหมคะอาจารย์ว่าเที่ยงคืนเนาะ
โอเคเที่ยงคืนอันนี้กลุ่มที่อะไรเมื่อกี้
กลุ่ม3ค่ะอาจารย์
กลุ่ม3ใช่ไหมกลุ่มอื่นมันจะคล้ายๆกันแล้วมั้งหรือเปล่าเดี๋ยวนะฮะมีอะไรบ้างอันนี้มี4เดี๋ยวแป๊บหนึ่ง
อาจารย์ครับ
ครับ
คือประเด็นคือไอ้พวกผมทำคำนวณออกมาแล้วคือผมไม่รู้ส่วนมากเนี่ยจะไม่รู้ว่าต้องไปเอาคอมแพร์กับอะไรแบบนี้มันจะค่อนข้างงงนิดหน่อยครับอาจารย์เพราะแลบที่แล้วมันสามารถยังคอมแพร์ได้นู่นนี่นะคือผมไม่มีตัวเลขในมือเพื่อที่จะคอมแพร์อาจารย์ส่วนมากนะครับที่ถามกันมา
เหรอ
ใช่ครับ
มันมีอันนี้อยู่sorry but this information is in Thai เกณฑ์อันนี้ผมอยู่ในหน้าจอที่เป็นอินเทอร์เน็ตอยู่นะใช่ไหม
ใช่ค่ะอาจารย์
โอเคเอาของอันนี้แล้วกันนะฮะMetropolitan Waterworks Authority แล้วกันนะฮะMetropolitan Waterworks Authorities actually there are two types of the standards one it could be the criteria and also from the Ministry of the Public Health the Department of กรมอนามัยนี่เรียกว่าอะไรวะ Sanitation ไม่รู้เหมือนกันนะฮะเอานี้แล้วกันนะฮะMetropolitan Waterworks Authorities. This one is the criteria. The suggested criteria. Actually, it's the specifications, not the standard. It's not the standards. Okay, it's the specification. Like these Metropolitan Waterworks Authorities, if they want to produce the tapped water, the qualities of the tapped water they produce should have a kind of the characteristic following these criteria, these specifications. For example, the coliform bacteria shouldn't be found in a sample of 100 milliliters. E. coli shouldn't be found. Now let's have a look for the other parameters. Physical and chemical quality. Color should be less than 15 units. You all know that. Turbidity should be less than 1. You see, this even more stringent. This specification is more stringent than the normal standard. So the standard is a 5. The standard normally prepared by the Pollution Control Department that is legally enforceable. But this one is not legally enforceable, but it's the specification. Free residual choline. Free residual cholines should be in this range. The free residual choline should be in this range. What we were talking about, the chloride. Chloride should be 250 milligram per liter. This is the specification, but please be noted that the Metropolitan Water Works Authority, they have the water treatment plant, and in their water treatment plant, they don't have like unit operation and unit processes to remove the chloride from water. If the raw water contains the chloride, like a 500 milligrams per liter, so 1000 milligram per liter, I mean the raw water, especially this time, sometimes the water in the Chao Phraya River, the chloride reach above 1000 milligram per liter. So they actually they don't have the facility to remove this parameter. So if the raw water contains chloride like a 500 milligrams per liter, whatever it is coming in, it is going out. The chloride is just like that. So as it is the conservative substance, so whatever it's coming in, it's just going out. So if it's coming in 250, so it will leave the treatment plant with the same concentration, approximately same concentrations, maybe 250 or 260 maybe. So it's more or less the same influence and effluence. So I'm talking about the water treatment plant. As I told you, 250, it doesn't affects or poses any negative impact to the human health, but the consumer, maybe they don't like if the tapped water contains the chlorides higher than 250 because it gives the salty taste. So I'm talking about the chloride, okay? But anyway, at the end of this table, there's a remark here, number 4. They said like for the free chlorine residue at the end, at the point of use, the free chlorine residue should be in the range of 0.2 to 2 milligrams per liter. The thing is, they don't want free chlorine residue get less than 0.2. If it's over 2, maybe it causes the problems about the smell. But if it's less than 0.2, it's critical because some of the germs, some of the pathogens may grow up if we don't have choline left in the piping system. So it is just monitoring a parameter. It's not a kind of standard that we have to strictly follow. Okay. Okay. Talking about this, and I have seen something interesting. This one. This is the microcystin. This one is the toxins. It's a toxic substance produced from some types of the algae. So for the ponds which rich in terms of the algae grows up.
some types of the algae, they released the toxic substance called the microcystin. So we should be careful if we take the water from, if we use the water from the ponds which experienced the eutrophication problems, because some of the toxic substance may get into the water, into the raw water, and then once we consume it, we also consume this toxic substance. This is very toxic. Even very small a quantity. See the specification, they mention only 0.001 milligrams per liter. The smaller values will be, the smaller values indicates the toxicity of the substance. For example, inorganic mercury, the allowable levels is just 0.006 milligrams per liter. Right, talking about the mercury, actually there was the episodes, the people experienced the disease, the people who are accidentally uptake the mercury suffer a lot from the Minamata disease. Have you ever heard about that? That is why the mercury, the allowable limits is just 0.006, similar to the cadmium. This one also 0.003 only. That's maximum allowable limits. So the smaller allowable limits is indicating the level of the higher levels of the toxicity. Okay, and what about the groups 4? Let's have a look at this copy. This resource presentations is not. It's difficult to to look up. Many parts of discussions were missed. โอ้อันนี้ดีจังเลยมีรูปด้วยอ๋อใช่ผมบอกให้ใส่รูปมาไม่ใช่เหรอนะฮะให้นักศึกษาใส่รูปมาด้วยนะฮะเพราะจะได้รู้ว่าใครเป็นใครนะครับอันนี้อาจจะค่อยยังชั่วหน่อยsignificant figures นะฮะ 240 อันนี้ก็เหมือนกัน and whatever chlorine tapped water this one is total chlorine okay so this one is the free chlorine underground water rooftop it seems to be the free according to the specification that I just showed you, they only mention about the free chlorine. They didn't mention about the total chlorine. Okay, the total chlorine refers to the combinations of free chlorine and chloramine. but it doesn't mean like in the tapped water, or you get the total choline approximately 2.2 milligrams per liter, and free choline 1.75 milligrams per liter. So it doesn't mean that the remaining means if you take 2.2 subtracted by 1.75, that is the remaining. It doesn't mean that the remaining is the chloramine. Total choline, it's the combination of the free choline and chloramine. But I just told you that total choline, it's a combination of free choline plus a chloramine. What is the chloramines again? Chloramine is choline associated with the ammonia. It could be a monochloramine, dichloramine, trichloramines, and whatever the forms. Free cholines refers to HOCl, OCl log minus Cl2. So these forms are considered as the free choline. According to this analysis, you have got like a 2.2 for the total choline, and free choline is 1.75. You just compare it with the specifications or the guideline, or probably there is no standard, as I said. But anyway, just compare with the specifications of the criteria. But you shouldn't discuss like a according to this number, chloramine is equal to 2.2 minus 1.75. We cannot come up with this kind of conclusion. Why? Because some of the free choline. So actually, it may be 99% may be a free choline. 99% of this 2.2 milligrams may be a free choline, but due to some reasons, free choline is vaporized. So we measure at the end, we have found the free cholines only up to 1.75 only. So this may not be true. So there are thousands of reasons. There are a number of reasons that the free cholines get vaporized or get lost from the sample. So this is not meaningful to confirm the results to discuss it like this. So you just compare with the specification that is good enough in case of the free cholines and the total choline. Okay. So at the end, what are the discussion points you come up with? These are just the results explanation. So be careful, results explanations and discussions are totally different. Okay, I think we have seen at least 4 to 5 copies of the report. So if you wish to add more or revise the discussion, you can do it and resubmit it again within tomorrow. And tomorrow is a holiday. Anyway, if you wish, you can submit. Tomorrow, by the way, tomorrow it's a holiday. It's Makabusha days, like people mostly goes to the temple and pray. With regard to the lab report, do you have any question? มีคำถามไหมครับ
อาจารย์ครับค่า DF สำหรับพวก conductivity หรือว่าสำหรับ sample เนี่ยพวกหนูต้องคูณไหมคะอาจารย์
คูณ
แล้วทำไมตะกี้ที่อาจารย์บอกว่าของกลุ่ม3อะค่ะของ
มันเยอะ
พิชพัฒน์อะค่ะที่เป็น10,000นะคะคือพวกหนูอะคูณกับ dilution factor ที่เป็น100อะค่ะอาจารย์ให้100มาพวกหนูก็เลยไปคูณใช่แล้วมันเป็น10,000เลยพวกหนูทำผิดไหมคะหรือว่า
ก็คงไม่ผิด แต่ว่าอาจจะลองตั้ง
สงสัย
เป็นข้อสังเกต discussion ไว้นิดนึง ว่ามันเป็นเพราะอะไร หรือว่ามันมีอะไรที่มันดูเป็นอะไรนะ ความเป็นไปได้หรืออะไรอย่างเงี้ยนะฮะ
ก็คือถ้าสมมติว่าอาจารย์ให้ค่า DF มาวันหลังก็คือพวกหนูต้องคูณด้วยใช่ไหมคะอาจารย์หรือว่าค่าที่อาจารย์ให้มามันคูณอยู่แล้ว
มันไม่น่าจะคูณนะ ถ้าให้ไปอย่างนั้นนะถ้าให้ไปแบบนั้นนะ โดยทั่วไปนะฮะเพียงแต่ว่าตัวเลขมันอาจจะexaggerate ไปนิดนึงนะถ้าดูจากเมื่อกี้นะ
ผมยังครับ
อะไรฮะ
ที่มันไม่มีโฟลเดอร์ขึ้นให้อ่ะครับ ที่ผมแจ้งอาจารย์
โฟลเดอร์อะไรอ่ะ
ของพานุพงศ์
มันปัญหายังไงนะ
คือมันไม่ขึ้นโฟลเดอร์ให้ส่งงานครับอาจารย์ผมเลยส่งไม่ได้
คุณอยู่กลุ่มไหนอ่ะ
ผมอยู่กลุ่ม3ครับ
coordination เนี่ยใช่ไหม
ใช่ครับผมส่งในแชทอาจารย์เลยครับก่อนเที่ยงคืนเพราะว่ามันไม่มีโฟลเดอร์ขึ้นมาผมแคปให้อาจารย์ดูแล้ว
กลุ่ม3มันต้องมี7 คนทำไมในนี้มันมี6 คนสงสัยตกไปมั้งไม่ได้คลิกแอดเพิ่มกลุ่ม3มันต้องมี7 คน1 2 3 4
คือจริงๆรายชื่อผมมันอยู่กลุ่ม4ครับอาจารย์แต่ว่าพออาจารย์ส่งงานมาคือผมได้งานของกลุ่ม3อะครับผมก็เลยทำงานของกลุ่ม3
ของคุณอยู่กลุ่ม3ไม่ใช่4
คือตอนแรกอาจารย์ตอนที่อาจารย์ให้รายชื่อรอบแรกอะค่ะของเขาอยู่ที่กลุ่ม4แต่พออาจารย์ปรับเปลี่ยนรายชื่อมันกลายเป็นกลุ่ม3อะค่ะอาจารย์
ใช่ของเขาต้องมาอยู่กลุ่ม3ตอนนี้เนี่ยเพราะว่าเรามีตอนนั้นคนลงทะเบียนเรามีอยู่25 คนตอนนี้คนลงทะเบียนเรามีอยู่27 คนกลุ่มมันก็เลยเลื่อนขึ้นรายชื่อก็เลยเลื่อนขึ้นเพราะฉะนั้นต่อไปนี้คุณอยู่กลุ่ม3นะฮะ
ได้ครับแล้วงานผมถือว่าอาจารย์รับทราบเลยใช่ไหมครับ
ก็ส่งเวอร์ชันไหนมาก็เวอร์ชันนั้นละฮะของคุณเวอร์ชันของกลุ่มอะไรล่ะ resource เนี่ย
เวอร์ชันกลุ่ม3ครับ
ก็กลุ่ม3นั่นแหละครับ
ได้ครับอาจารย์ขอบคุณครับ
ฮะโอเคเรื่องอื่นมีอีกไหมครับผมเน้นย้ำนะว่าเวลาส่งงานเนี่ยงานเนี่ยไม่เท่าไหร่ละแต่ว่าตอนสอบเนี่ยนะฮะเวลามันจะเป็นตัวล็อกนะครับนะฮะมันระมัดระวังกันนิดนึงนะครับ
อาจารย์แอบใบ้ให้หน่อยได้ไหมคะว่าสอบมันจะมาเป็นแบบว่าแนวไหนจะได้เตรียมตัวเตรียมใจนิดนึง
แอบใบ้ใช่ไหมฮะ
แอบใบ้
ยากส่วนมากเป็น critical thinking นะครับ critical thinking
คำนวณเยอะไหมคะอาจารย์
เมื่อวานมีคนถามผมอยู่เรื่องหนึ่งเป็นคำถามที่น่าสนใจมากอันนี้ผมจะบอกข้อสอบเลยก็ได้มีอยู่ข้อหนึ่งนะฮะถ้าคุณกลับไปดูใน lab direction นะ instruction manual เรื่อง coordination ดีๆเดี๋ยวผมเปิด instruction manual หน่อยมันอยู่ที่ไหนเนี่ย class material มั้งinstruction manual นะฮะเรื่อง coordination coordination ใช่ coordination there are 2 methods total Colline determinationเดี๋ยวนะโอเคoh not this one เจอละนะฮะ free Colline residual ไปอยู่ไหนthis method นะฮะ this method here it is mentioned like if the total chlorine exceed 5 milligram per liters use a smaller sample and diluted to the volumes of 100 ml. What does it mean? A free chlorine residual determination by this method, DPD method. เขาบอกว่าไอ้ตรงนี้เขาบอกว่าอย่างถ้ามันเกิน5มิลลิลิตรเนี่ยเราก็จะต้องใช้ตัวอย่างที่มีขนาดเล็กกว่านี้นะฮะคือถ้าสมมติว่าวัดออกมาแล้วคลอรีนเป็น7อย่างเงี้ยเราก็ต้องเจือจางพูดง่ายๆนะฮะเราก็จะต้อง dilute นะฮะมี dilution factor ออกมานะครับถ้าสมมติว่าเราใช้เป็นข้อมูลอย่างเช่นเราใช้ DPD method ใช่ไหมแล้วก็มีตัวเลขมาให้แบบที่ตารางในตารางแลบอย่างเงี้ยนะฮะแล้วผมถามว่าข้อมูลนี้มันจะน่าเชื่อถือไหมถ้ามันไม่มีinformation เกี่ยวกับเรื่องของการเจือจางคำถามจะเป็นลักษณะแบบคล้ายๆเขาเรียกว่าอะไรทั่วๆไปนะฮะที่มันเป็นเรื่องของความน่าเชื่อถือมั่งเป็นเรื่องของอะไรวิจารณ์การนำเสนอผลวิเคราะห์ผลอะไรประมาณอย่างเงี้ยฮะคล้ายๆแบบนี้คล้ายๆกับที่ผมพูดอยู่ทุกๆครั้งเวลาเราดิสคัสเกี่ยวกับเรื่องของรีพอร์ตตอนหลังๆมานี้เนี่ยนะครับส่วนใหญ่จะเป็นอย่างนั้นแล้วก็มี situation บาง situation ให้มาที่บางทีเราอาจจะต้องแก้ปัญหานะฮะเกี่ยวกับเรื่องของอะไรบางสิ่งบางอย่างอย่างเช่นเราวิเคราะห์น้ำตัวอย่างเพื่อที่จะดูพวก alkalinity ปรากฏว่านะฮะ alkalinity เนี่ย at the end point เนี่ยนะฮะyou have to observe like the colors of the indicator changes from yellows to the first turn orange for example but if the water sample you get it is the samples we collected from theอะไรนะ septic tank for example so it turned dark so it gives the black colors so if the sample turned black you added indicators yellow colors and you expected the color changes to the first turn orange so how do you observe the colors at the end if the original sample is black so for this situation how you will tackle or how do you overcome these problems how จะแก้ปัญหายังไงไอ้ประเภทอย่างเงี้ยคำถามประเภทอย่างเงี้ยนะก็ลองฝากไปคิดดูนะส่วนใหญ่แล้วจะเป็น critical thinking นะฮะว่าจะเป็นลักษณะยังไงนะครับ
แสดงว่าคำถามก็จะไม่มีแบบตายตัวอะไรขนาดนั้นใช่ไหมคะเพราะว่า
ไม่มีตายตัวคือ
แต่ละคนก็อาจจะได้แบบคิดไม่เหมือนกัน
อาจจะไม่เหมือนกันฮะอาจจะไม่เหมือนกันนะครับนะแต่ว่ามีบางคำถามก็อาจจะต้องเหมือนกันนะตอบไม่ถูกนะฮะ อาจจะต้องเหมือนกันบางคำถามก็อาจจะต้องเหมือนกัน บางคำถามก็อาจจะไม่เหมือนกันนะครับ อาจจะมี 2-3 วิธีนะฮะบางคนอาจจะบอกว่าบางคนอาจจะตอบมา2วิธีตอบมา2วิธีอาจจะให้เต็มอะไรอย่างเงี้ยนะฮะได้คะแนนเต็มตอบมา1วิธีอาจจะได้คะแนนประมาณสัก8ส่วนนะฮะตอบมา0วิธีคะแนนอาจจะเป็น0ส่วนเลยอันเนี้ยนะครับนะฮะมันจะมีวิธีการไม่เหมือนกันนะครับประมาณนี้
อาจารย์ครับตอนสอบเนี่ยพวกหนูสามารถเปิด iPad ได้ไหมครับแบบเปิดที่เราจดไว้ค่ะใน iPad
It's open book feel free to open your resources materials ทุกสิ่งทุกอย่างเปิดได้หมดฮะ
แต่เปิด iPad ได้อยู่ใช่ไหมคะอาจารย์อนุญาต
เปิดได้แต่ว่า
โอเคครับ
ห้ามอยู่อย่างเดียวก็คือห้ามสิ่งที่ไม่ต้องการคือประเภท communication ระหว่างเพื่อนในคลาสนะฮะแต่ถ้าคุณสามารถที่จะค้นคว้าได้อย่างอิสระอินเทอร์เน็ตหรืออะไรเชิญตามสบาย
อาจารย์คะมันมีประมาณ
แต่
กี่
สิ่ง
ข้อ
ที่ผมไม่ต้องการคือสื่อสารระหว่างกันส่งข้อสอบระหว่างกันส่งคำตอบระหว่างกันอันเนี้ยไม่ต้องการครับอะไรนะฮะ
กี่ข้อนะคะอาจารย์
ไม่รู้ฮะอันนี้ยังไม่ได้ออกข้อสอบมีแล้วแต่ว่ายังไม่ได้เอามาจัดเรียงออกแล้วบางส่วนแต่ว่ายังไม่ได้เอามาจัดเรียงบางส่วนที่เคยมีอยู่ในคลังก็ต้องตัดทิ้งไปเพราะว่ามันเป็นข้อสอบแบบออนไลน์ก็เลยต้องแบบเปลี่ยนคำถามเปลี่ยนอะไรใหม่ฮะแต่ว่ามันยังไม่สมบูรณ์คิดว่าน่าจะสมบูรณ์ภายในวีคเอนด์นี่แหละนะครับมีข้อสอบปีก่อนๆก็ลองไปดูก็ได้นะฮะมีข้อสอบถ้ามีข้อสอบปีเก่าๆนะครับพวกรุ่นพี่บางทีจะมีนะฮะถ้ารุ่นพี่มีก็มาแจกจ่ายรุ่นน้องด้วยนะฮะไม่ใช่อุบดูอยู่ ฝ่ายเดียวนะครับครับมีคำถามอื่นเพิ่มเติมไหมครับถ้ายังไงเดี๋ยววันพฤหัสหน้าเรายังเจอกันเหมือนเดิมนะหมายถึงว่าอาจจะมี discussion เกี่ยวกับเรื่องของ report ของ